Hi, this is Albert Lombarte, and in this video I'm going to show you KrakenD Playground, a Docker Compose environment that stars our API Gateway along with other third-party services, so you can see integrations like logging, metrics, tracing, or authorization. It's everything configured already. All you have to do is a Docker Compose app and play with the gateway and the different endpoints that we have set as an example, and that's it. But I want to stay in this video with you so you can see the whole process of cloning and starting the project, and more importantly, understanding the configuration files. If you understand the configuration files, then it's very easy that you can start your next live project. As you can see now on my shared screen, I have two windows open, one for Playground Community, another one for Playground Enterprise. As you can notice, it's essentially the same product. The only difference is the Playground Enterprise has more functionality. So you will see more endpoints and with different options that are not available to Kraken open source edition. But we are going to stick with a Playground Community for now, as it shows for the purpose and works both for Enterprise and Playground. So let's clone our repository. You can also download the zip, but I'm going to clone this in my desktop. So let's do git clone. Okay, so the product is now cloned. All we have to do is we have to enter and do a Docker Compose app. Now Kraken will start all of the services that are in this demonstration. Meanwhile, I'm going to open the code. Okay, the first file we are going to focus in is the Docker Compose. The Docker Compose shows the different services that we are going to see in this demonstration. You don't need any of these services to run KrakenD except Kraken itself, but it shows different ways of integrating KrakenD with third-party services. The gateway only needs the image. In this case, we have this watch label. You don't have to use this in production because it will restart KrakenD every time there is a configuration file, and this is not suitable for production, but it speeds up a lot when we are developing. So every time that we save the configuration, we can see the changes live. KrakenD runs on port 8080. There are two additional ports that we are not going to use right now, which one is for the Bloom filter or the token revocation system. This is a port that listens RPC connections to invalidate tokens that are still valid. We are not going to see this in this demonstration. And there is an 8090 port which offers stats endpoint, which shows metrics about memory usage and other useful stuff. We are going to focus on the API Gateway functionality itself, which will run on port 8080 in our machine. The next service I want to show you is our upstream services. That's what our API would be. So if your company has already backend APIs, this is the service that is going to emulate that response. It feeds from this data. This is static data, so as you can see here, these are a few JSON responses that we have here. This is going to emulate the response of our regular API. Let's see now the Kraken configuration. The Kraken configuration is a simple JSON file, although it can be split into many files, as we can see here. But we are now using only this Kraken JSON file, which is a unique file that contains everything that the API Gateway needs to do. The Kraken JSON structure is, first of all, there is like a global level attributes, like the version of this syntax file and the port, the default timeout for all the endpoints, etc. And then there is this extra configuration that applies to all of the system. This extra configuration contains things like the telemetry. So if we want to push logs somewhere out, or if we want to store our metrics in an InfluxDB database, all of this is configured here. This is all optional, and we will see a few of these integrations in this demonstration. An important field to see here is the host field. The host field is where KrakenD is connecting to. So I can specify where Kraken connects to for each backend. But if I do not write this on the backend, the connection will use the default host. So this is actually an array, as you can see, meaning that if we have more URLs, KrakenD will load balance each of the elements in the list using a round-robin fashion. The endpoints contains our API contract. KrakenD is not just a proxy, but it's a system that can connect to multiple places at once. So in this case, when a user connects to git/user, what we will have is that KrakenD will connect in parallel and simultaneously to two different backends. The backends are your upstream services. So in this case, we are using an external source, which is apigithub.com, and we will connect to this user/user. So essentially what we are doing is that we are connecting to this URL on api.github.com. So let's see the response of this API. So I will use my username on GitHub, and as you can see, there are a few fields that are returned by api.github.com. Let's get back to the configuration. From this response, we only see a few items, so we don't see the full response. We want only these items that are listed here. So when this API is requested to KrakenD will hide anything that is not in this list. Similarly, we can use the deny. It works the same way, but the only thing that it does is that it hides those attributes. This is the basic manipulation options. Another basic manipulation option that we have is that we can do a mapping or a renaming of attributes. So if we go back to api.github.com, we can see that there is field blog in here, but this is actually not a blog site. This is our website. So we want to rename this, and we will change any appearance of blog by website. So KrakenD is going to rename all of that at once. And finally, since we are connecting to two different backends, and I'm calling this URL on GitHub, and then I'm connecting also to this other URL, user/repos, I want to see all of this response encapsulated inside this user group. So let's see how this works first. Let's connect to, now instead of the apigithub.com, we will connect to the KrakenD Gateway. Okay, so here we have the response that we were looking for. The repos is the response from the second backend call, and the user is from the first API call. As you can see, it does not contain all of the fields that we had on api.github.com, and this block has been renamed to website. So we had here basic manipulation, and we have one call from api.github.com and another call in here. Repos is a collection, so this is an array, and it's treated differently, but essentially it's the same information all together in one endpoint. Okay, let's see now the cached endpoint. This market cached endpoint, what it does is that connects to coingecko.com, to this URL pattern, and the response of the backend is stored in Kraken memory for subsequent calls. Okay, so this HTTP cached middleware is enabling the cache for this backend. So let's call this endpoint. Let's do a CURL. Okay, so when we call this CoinGecko API, we see that there is cache control header, which allows KrakenD to store the content for 300 seconds or 5 minutes. So this is the TTL that is going to be saved in Kraken memory, and there is no way to tune that from this middleware. There are other middlewares that might help you change this cache control header before Kraken actually catches the content, so you can override the TTL, but the middleware is just a flag that tells you if you want to cache or not. So when I call now the same URL through KrakenD, so now KrakenD has cached the content in memory. So if I ask it again, this content is served from cache. There's nothing that you can see here because both calls were very fast when we went to the origin and when we requested through KrakenD. But this kind of information is something that you can see on the tracing monitoring. One of the things that we also have running in this demo is a Jaeger tracing system. So Jaeger is storing whatever it happens between the different systems. As you can see here, the first call that I did to the market cached when we had no cache is that KrakenD had to fetch the content from the remote server, and that took 260 milliseconds. The next request that I did from the terminal was already cached, so it only took 371 microseconds. So as you can see, there is a massive improvement when you use the cached. You have to be very aware when using cached because the cache control header is set by the backend, and you have to make sure that all the content that you want to store on KrakenD, it fits in the memory. So if you want to store large amounts of backend calls for a large amount of time, you have to be aware that your memory consumption will increase a lot. User rate limit. In this case, what we see here is that this products.json URL is going to be rate limited, so KrakenD cannot do more than one request per second to the backend. In the endpoint rate limit, which is at the endpoint level, this is this one, we see that there are 2 requests per second that the user can do to KrakenD. So the user is rate limited to 2 requests per second against KrakenD, and KrakenD itself is limited to requests from this specific backend to 1 request per second. As we don't have the rate limiter in this backend has no limit. So what happens? The user connects to shop, KrakenD connects to this shop campaign's URL, gets the information without any limit, and it also at the same time gets information from the product's URL, but it's rate limited to 1 request per second. So our end user will be able to do 2 requests per second at top, but if it does more than 1 request per second, then we'll only see this backend response because this one is rate limited. Okay, so let's see how this works. Okay, so we have requested our shop endpoint. As we can see here, this endpoint is returning all the information that we want. It contains the campaigns array, and it also contains the products array. Okay, so it contains the calls of the 2 backends that we did. This returned at 200 OK, and the X-Kraken complete true tells us that everything worked and everything is contained in the response as expected. When one of the 2 backends fail, you will see an X-Kraken complete false. Now let's stress this a little bit. So let's do it first manually instead of doing a stress tool. So I will do this CURL faster. I requested several times. What I can see here is that I had the X-Kraken complete false. That means that our product's URL failed because I exceeded 1 request per second. So KrakenD wasn't able to fetch the product content because it's rate limited, and we have a partial response. This X-Kraken complete false is telling us that you have a partial response. So the policy of KrakenD is return whatever you can. Okay, so it doesn't have any kind of retry or any other policy. So our policy is fail fast. In the next call, we see that there is an X-Kraken complete false again, because we have also exceeded the 1 request per second limit. And on the last call, we see a 503. So we are not returning anything to the end user because it's the end user who passed the 2 requests per second limit. Okay, so in that case, the rate limit that enter into action is this one. It's the user rate limit. Let's jump now to another functionality. What I want to show you with this endpoint is the concurrent calls. The concurrent calls is an efficient way to get content faster than you would actually get from your backend directly. How is this possible? When a user calls KrakenD, KrakenD can make 1 or more calls to the same URL. So in this case, we are accessing this URL. I'm going to simplify it like this. So the user calls Kraken, and Kraken calls this coins endpoint. What the concurrent calls does is that instead, we are going to let KrakenD query more than once the same URL pattern. So in this case, we will do this 3 times. KrakenD will call these 3 endpoints asking for the same information, and it will answer with the fastest successful response that gets from the backend. So let's say that this backend endpoint is the first to respond. What Kraken is going to do is going to cancel these calls and return to the user this information. Okay, so what we do with this technique is that we apply more pressure to our backend, so our backends receive more traffic, but in exchange, we usually receive 70% faster responses, because the fastest backend is the one that is served to the end user. So obviously, you cannot do this when you have one single server behind, but when you work in clusters and you have multiple machines sharing the information, KrakenD can increase a lot the experience that the end user has with your API. Let's try it and see on Jaeger how this performs. So what I'm doing is I'm calling this endpoint. And now let's see on Jaeger what happened. So if we go back to Jaeger and find traces, we can see here these concurrent calls. Kraken did 3 calls and took the faster response. So here we can see all of these calls, how they returned the content, and Kraken returned the fastest one. We can see here that Kraken performed 3 different calls to CoinGecko, and we can see that this actually took different times. So KrakenD is going to return the faster response and will discard the rest. So of all these, KrakenD only returned one of the responses to the end user. But what we have with this is that we increase a lot the user experience. The next endpoint I want to show you is the sequential endpoint. The sequential endpoint uses a different mechanism to get information. As we saw in previous endpoints, KrakenD was connecting in parallel to get the information from the backends, but in this case, what we are going to do is we are going to connect to this URL pattern, this hotels1.json, and KrakenD will wait for the response. Once the response comes back from this URL, KrakenD will fetch the destination ID that is included in the response and will inject this destination ID in the second call. So what is happening here is that KrakenD is actually doing a cascade. So until it doesn't have this information, it won't call this other endpoint. What you can do with this is that you can inject information from one call to the other and get a dependency resolved by Kraken. Okay. To enable sequential, only we have to do is in the extra configuration of this backend, we have to enable the flag sequential. So let's call this sequential endpoint now. So I got this information, and once more, let's go into Jaeger and see what happened. Okay, so now we can see this sequentiality in this map. Kraken called this hotels1.json. It took 950 microseconds, but as you can see, Kraken needed to wait to start this connection for the destinations endpoint and needed to wait until the hotels endpoint returned the information. The destinations ID was injected as part of the URL, and then we got the full response in 1 millisecond. Okay, another endpoint that I want to show you now is the mock response. The mock response is that it's a functionality that allows us to return random static content, so we can write here any response that we want. And this is useful when we are creating an API for the first time, so the backend is still not ready, but we want some mock data to work with. Or maybe we can use this when our real backend fails. So in strategy, we specify when we want to return this static data. In this case, we are going to return it every time. So if I ask for this mock response, what I'm going to see is the static data that we have specified in here. Okay, so what we see here is exactly what I specified in the configuration. There are other strategies that you can use. So for instance, when your backend fails, you can inject the static data. If it doesn't fail, you don't want to do it. So that's also a mechanism of having a fallback in case there are problems with your backend. The final endpoint that I want to show you is how the authorization works. In this case, we have registered to Auth0, so I have an account on Auth0 that it takes care of all my tokens. And when I generate and when I log in through Auth0, what happens is that my browser stores a JVT token. In this job token is injected in every call that I do to the endpoint. So let's query this private Auth0 endpoint. So as we can see, I have no token right now. So this has returned an error. We can see it in the console. Okay, so we can see here that this is a 401 error, meaning that I don't have the permissions to enter. And I will show you now how this integrates in a website. So I have this basic Node application running on localhost 3000. This website is very simple, but as you can see, I can do a ping to KrakenD. This is calling KrakenD. I can call public endpoints, but I'm not authorized to call private endpoints. So in this case, so now I'm logging to Auth0 with my credentials. So I'm outside of KrakenD. I'm logging in, and this is storing in my browser a token. Now I'm able to do private calls. So I can see now this private endpoint that was protected by Kraken. So this is the piece of configuration that you need to start protecting your endpoints. There's nothing else that you need. In this case, we are making sure that the token contains one of these two roles. This is optional. We are also checking the token has a specific audience. We could also add here claims and scopes. We can do more validations before the user enters. But the basic here is that you need to specify the algorithm that you're going to use to sign the tokens and the JWK URL. Okay, so if you use Auth0, if you use Keycloak, Okta, any other system, any provider that you want to use, it can be integrated by just specifying this URL and the algorithm. So we have Grafana running on port 4000. All of this demo has been recorded here. You can access with admin and skip changing the password. So let's see now all of this activity that we have been generated, how it shows on Grafana. So Grafana is a metric system. We can see here that we have all these router requests that we send, and we can see average response time. We can see the maximum response time. There's a lot of information that we can see here, from the connections that we have per minute, how the response distribution, the router connections, etc. So there is a lot of information that it's useful here and that we can use to monitor our real life API gateway. And also enabling now the Elastic logs. So what I'm doing is that I'm importing a dashboard on Kibana. Kibana is also installed on this demonstration. So Kibana shows us the different logs that we have been heading during this demonstration. There are different dashboards that are installed. You can find them on dashboards. There are two different dashboards. One is the access log. This is how the users are accessing the endpoint, and this is the application log. So if there were errors that we had during this demonstration, which was the case because I stressed, for instance, endpoints with rate limiting, all of that will show in here. So we have the logs, the error logs, and we have the access logs, so we can see the activity. We did different calls. We were not consistent in the usage, so there were periods that we did not send any calls, but we can see here the top 10 URLs. This is an example of what you can get by passing the logs. All of that is done, and you don't have to spend the time to figure out how it works. All the configuration files are here, so you can import that into your project. This is an example of the Logstash, how we ingest the logs into Elastic. This is the expression that exports logs to Elastic. So it takes the log from KrakenD and pushes it to Elastic. And then we have these nice dashboards on Kibana. All the configurations are here, so you can explore how all of this works. One final thing that I want to show you is the async agent. The async agent is the capability of KrakenD on running by itself without any request from an end user to a REST API endpoint. What it is that KrakenD is listening to a queue, and when it sees that queue has new message in it, it processes those messages and sends it to a backend. So we could say that it's kind of a webhook, that when KrakenD sees activity on a queue, it will inject the content of that message on a backend or a multiple backends. So you can also send to more than one. We have our RabbitMQ running on this board. So this is our queue system for this demo. I'm opening this right now. Credentials are guest. In this demonstration, we see that we have this KrakenD queue that has been created when we started KrakenD automatically. Now, when we put some payload, KrakenD is going to consume that payload. So in order to see that, what I'm going to do is I'm going to show the logs of KrakenD. Okay, so that's the logs of KrakenD running. I'm going to push a new message into the queue. That's published. And now if we go to the logs, we can see that KrakenD has consumed that. And we see this debug endpoint with this debug async agent demo, which was exactly the URL that we had in the configuration that was supposed to consume the message. So in this post, when the message entered the queue, Kraken consumed it and called this debug async agent, which is Kraken itself, because this is Kraken consuming Kraken. And as you can see, the post was sent with the body a new message. So this is a very fast way to consume message from the queues. This system can process tens of thousands of messages per second, so it's very fast and can help you get you on board on an async pattern. I hope this session was useful. We saw the very basics of KrakenD, we saw aggregation, we saw how to integrate with third parties, we saw Kibana in action, Grafana, Jaeger. We also see how to use tokens from Auth0. This was very simple. Of course, KrakenD offers much functionality and you will need to spend some more time exploring those components that you are going to need and are not covered in this session. Feel free to ask any questions and I'm hoping that I see you again on the next video.